Yo, yo, yo! This is H by H. Today we're talking about a planet so suspiciously perfect, it keeps scientists awake at night, Kepler-22b. Please subscribe, and let's dive in. The story begins in 2009, when NASA launched the Kepler Space Telescope. Unlike Hubble, Kepler didn't snap glamorous photos. Instead, it was a patient accountant, staring at 150,000 stars at once, waiting for the tiniest flicker of light. Why? Because when a planet crosses in front of its star, it blocks just a sliver of light. Astronomers call this the transit method. Simple in theory, insane in practice. Imagine lighting a candle 100 kilometers away, then waiting for a mosquito to pass in front of it. That's what Kepler was doing, but with stars. The numbers are brutal. A typical Earth-sized planet blocks only about 0.01% of its star's light. That's like your neighbor turning off one Christmas bulb, and you noticing from across the country. And to prove it's not just noise, Kepler had to see this exact dip 3 times, at perfect intervals. When I first read that, my brain went, "Holy moly, sweet cosmic donut, this is wizard level astronomy, blah blah blah, beep beep boop boop." And yet, Kepler actually pulled it off. In 2011, after 2.5 years of meticulous data checking and countless error eliminations, NASA confirmed the existence of Kepler-22b. It wasn't just another planet. It was the first confirmed world in the habitable zone of a sun-like star. Translation: humanity's first solid evidence of another place that could, in theory, host life. 2. Why it's so weird. At first glance, Kepler-22b seems like a dream. It's about 600 light-years away, orbiting a star very much like our Sunday. Its orbital period is 290 days, so its year is almost the same as ours. Its orbit is 0.85 astronomical units, a perfect distance for temperate conditions. Now here's the kicker. If this planet has an atmosphere like Earth's, its average surface temperature would hover around 2 degrees Celsius, a permanent spring. Imagine a world where it's always t-shirt weather. No freezing winters, no boiling summers, just picnic season forever. Sounds amazing, right? But science has a way of turning dreams into puzzles. The first red flag, size. Kepler-22b is about 2.4 times the radius of Earth. That places it squarely in the so-called Fulton Gap, a mysterious missing zone between rocky planets and gas giants. Planets this size just aren't supposed to exist, or at least not in stable form. Picture this. You walk into a zoo, and there's a gorilla standing 2.4 meters tall, taller than a basketball hoop. But instead of looking like a gorilla, its body proportions are all wrong, like someone mixed the wrong Lego pieces. That's Kepler-22b. And my brain just screams, "Holy guacamole, motherfucking marshmallow meltdown, what even is this thing, zap zap dead, bop bop bop." Too big for rock, too small for gas, stuck in a category we never expected. Then comes anomaly number 2, the orbit. Most planets wobble. They're tugged by neighbors, pulled slightly off-center. Their paths are messy, eccentric. But Kepler-22b, its orbit is practically a perfect circle. No wobble, no tilt, no sign of disturbance. It's like someone took a compass, drew a circle, and said, "Here, stay put." Sweet banana pancake. Perfect circle nonsense. Ding ding ding, boop bop bop. Holy smokes. Not only does it sit in the habitable zone, it's dead center. And the rest of the system? Empty. No moons, no sibling planets, no leftover debris. Just one star, one planet, and silence. Too clean, unnaturally clean. 3. What scientists think. Faced with this cosmic oddball, scientists have tried to make sense of it. Over the years, 4 main theories have emerged. Theory 1. A super-Earth with a thick atmosphere. Maybe Kepler-22b is rocky like Earth, just bigger, wrapped in a dense atmospheric blanket. That would explain the size. But here's the catch. Too much atmosphere, and you get a runaway greenhouse effect like Venus. The surface would be a high-pressure oven. Too little, and the numbers don't add up. Simulations end up stuck always close, never quite right. Theory 2. An ocean world. Imagine a planet covered entirely by water, hundreds of kilometers deep, a world of endless blue. Sounds poetic, but biology needs more than water. Without continents or active geology, there'd be no nutrient cycling. Life might exist, but forever trapped as microbes, never evolving complexity. A beautiful, sterile fishbowl. Theory 3. A mini Neptune. Perhaps it's not rocky at all, but a small gas planet, like Neptune's baby cousin. The problem? Mini Neptunes shouldn't form this close to their star, unless it was born farther out and migrated inward. But then what force dragged it, and why did it stop so perfectly at the habitable zone's center? Theory 4. A hybrid planet. Some simulations suggest Kepler-22b could be a layered mix, rocky core, massive water shell, thick atmosphere. Possible, yes, but the fine-tuning required is ridiculous. It's like rolling dice a million times and hitting the exact same number every single throw. Possible, but not natural. Each theory works on paper, but when you run the math, every path circles back to the same wall. Almost, but not quite. Kepler-22b refuses to fit. 4. Too perfect to ignore. And here's where it gets spooky. It's not just one anomaly, it's all of them, stacked together. Its radius? Exactly 2.4 Earths. Its orbit? Almost a perfect circle. Its year? Practically our own, 290 days. Its temperature? 22 degrees Celsius, a permanent spring. One coincidence? Fine. 2? That's lucky. But 3, 4, 5 in a row? At that point, my brain is
holy moly, jelly donut roller coaster, cosmic burrito backflip, ding ding dang, wham bam boop.
Too many just rights in one place, and you start wondering if the universe is trying to tell us something. Now, let's be clear. No one is saying Kepler-22b was built. But when a planet looks this perfectly tuned, it forces uncomfortable questions. Is it an invitation? A reminder? A specimen in some larger cosmic experiment? Maybe Kepler-22b will never give us answers, but it demands that we ask better questions. Perhaps our models of planet formation are too narrow. Perhaps what we think is rare is just our tiny sample size. Or more provocatively, maybe the universe really does plant sample worlds to shake us out of complacency. Either way, Kepler-22b stands as a mirror. It shows us the limits of our knowledge and the power of curiosity. Closing. I'm H by H, your friend who spins bedtime stories just for you. Until next time, sleep well and dream big.